So next we're going to be talking about the properties of rhombi. So remember, rhombi is multiple, rhombus is one. So rhombi have the same properties of parallelograms. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, and 3 additional. We have 4 congruent sides, so I'm going to write 4 congruent sides. Diagonals are perpendicular. Diagonals and the last one is that diagonals bisect opposite angles. So diagonals bisect opposite angles. Again, I wrote these for you in your notes, so you can choose to write them down on your own paper or refer to the notes for the properties of rhombi. So we're going to use these properties to solve for the missing side and angle measurements in the next few examples. So the first one says JK is equal to 12 and JN is equal to 7. So I'm going to just label right here, JK is 12, JN is 7. And now we need to find these missing sides. In order to find JM, we're going to use this property right here. It says for rhombi, 4 sides are congruent. So if JK is 12, then this is 12, this is 12, and this is 12. So that means JM is 12. Now we need to find JL. So JL is this entire thing. I'm going to highlight it in yellow. This is JL. If we know JN is 7, these two are congruent, so this also has to be 7. Keep in mind they asked for JL, so JL is the whole thing. 7 plus 7, that gives you 14. Now we need to find MN. MN is from here to here. Now, don't mistake this for properties of a rectangle, because if this was a rectangle, they would have been congruent, but that's not the case. So we have to actually solve for this missing side. We can use Pythagorean theorem again by looking at this triangle right here. We're going to look at this triangle in red right here. And I'm looking at this triangle because if I find MK, I'm going to call this X for MK. If I find X, then I'll be able to use that to find MN because they are congruent. So this is my right angle. And I know that this is my right angle because it says diagonals are perpendicular. So if diagonals are perpendicular, then I know that there's a right angle that exists right here. So I'm going to use Pythagorean theorem. A squared plus B squared equals C squared, where C squared is my hypotenuse. Remember, the hypotenuse is always across from 90-degree angle. So that means that 12 is the hypotenuse. So we have 7 squared plus X squared is equal to 12 squared. So we have 49 plus X squared is equal to 144. I'm going to subtract 49 from both sides. I have X squared is equal to 95. Take the square root of both sides. X is 9.7. So that means this is 9.7 and so is MN. They're both 9.7. So this is 9.7. They want us to find MK. MK is this whole thing right here. So we're going to add 9.7 plus 9.7, and that's going to give us 19.4. Let's try to use these properties to do another example. So let's look at this question. So we have another rhombus. This time we're solving for missing angles instead of missing sides. So let's start with the measure of angle 1. One of the properties of rhombus tells us that, if we go back, one of the properties of rhombus says that diagonals are perpendicular and diagonals bisect opposite angles. So this is a little different from rectangles. In rectangles, we had 4 right angles, but for a rhombus, these angles are actually congruent. So this is congruent to this is congruent to this one is congruent to this one is congruent to this one. So for the measure of angle 1 and 2, we can't find that just yet, but we can find the measure of angle 3. If these are congruent, if this is 38, this is also 38. So I'm going to write 38 right here. Now, another property, remember some of the properties of parallelograms apply to the properties of rhombus. So we're going to see that opposite angles are congruent and that consecutive angles are supplementary. So if we're looking at this example, we know that these two are 38, which means if you add these, you're going to get 76. These angles right here should be supplementary. So if you add 76 plus this angle right here, which is combining angle 7 and angle 6, you should get 180. So if you do 180 minus 76, you're going to get 104. Now this whole angle is 104, but 7 and 6 have to be congruent. So if you divide 104 by 2, you'll see that this is 52 and this is also 52. 52 and 52 gives us 104. So that's 6 and 7. So we know that these are 52. Remember, opposite angles are congruent, or another property that can apply is that alternate interior angles are congruent. So if you know that, you can find that this is 52 and this is also 52. So 52 and 52, which makes these both, you guessed it, 38. This is 38. This is also 38. Let me put my degree symbols. And the last one we need to find is the measure of angle 8. Remember, we said diagonals are perpendicular. So this has to be a right angle, which means this is a right angle, which means this is a right angle, which means this is a right angle. So the measure of angle 8 is 90 degrees. Let's move on to the properties of squares. So a square has all of the properties of a parallelogram, a rectangle, and a rhombus. So opposite sides are congruent. 4 congruent sides. Diagonals bisect each other. Diagonals are congruent. Consecutive angles are supplementary. All of these properties apply to a square. So we're going to use these properties to solve for the missing values in this figure. So it says if ABCD is a square and AD is 11, find each missing value. So we know that AD is 11. I'm just going to go ahead and start filling things in, because if we know that there are 4 congruent sides, then this is 11, this is 11, this is 11. And you can see over here, they asked for BC, so we already know that this is 11. Now they said to find AC. So in order to find AC, we're going to use Pythagorean theorem again. So I'm going to highlight this triangle right here. Remember, you still have your right angle. Your right angle is right here because a square has 4 right angles. So a square has 4 right angles. So that means that this side, I'm just going to call it X because that's what we need to solve for AC. That is my hypotenuse. If I'm going to use a squared plus b squared is equal to c squared, x is going to be my hypotenuse. It's going to be 11 squared plus 11 squared is equal to x squared. So we have 121 plus 121 equals x squared. This gives me 242 is x squared. Take the square root, and you're going to see that x is 15.6. So that means that AC is 15.6. They ask us for BD. That's another diagonal. Remember, diagonals are congruent. So if AC is 15.6, that means BD is also 15.6. We need to find EC. That's this little bit. If we know the whole diagonal is 15.6, we can divide that by 2 because we know these have to be congruent. So that means this is 7.6. Sorry, 7.8. And this is 7.8. So EC is 7.8. Now let's look at the angles. So I'm going to erase all of the things inside the triangle so we can just look at the angles. So if we're looking at the angles, it says the measure of angle DAB. DAB is this angle right here. And it is a right angle. And we know it's a right angle because a square has 4 right angles. Now we need to look for angle AEB. That is right here. We know that this is also a right angle because we know that the diagonals are perpendicular, which means they intersect at a right angle. So AEB has to also be 90 degrees. Now we need to find the measure of angle CBD. That's right here. If this whole angle, remember that's 4 right angles, so this whole thing has to equal 90. And because the properties of rhombi apply to squares, we know that this angle and this angle have to be congruent, but they also have to add up to 90. So if we do 90 divided by 2, we're going to get 45. So that means each of these in the square is 45 degrees. So CBD is 45 degrees, and then BAC, the same thing applies. This has to be 45. This has to be 45. In fact, all of these are 45, because this whole thing has to be 90. This has to be 90. That has to be 90. This has to be 90. These are just 90 degrees. This is 90. This is 90. This is 90. This is 90. So if you want to write this down, this will help you remember the value for the measures inside of a square. And this is always going to be the case. This is always going to be 45, 45, and there will always be 4 right angles. So BAC is 45 degrees. Let's try another one. So this time we're going to solve for the missing side or angle measurements in either a rhombus or a square. So it says if MNOP is a rhombus, find the measure of MP. So one thing that we know in terms of the properties of a rhombus is that opposite sides are congruent. So these two are equal to each other. So we can set them equal to each other and solve for x. So we have 9x minus 77 is equal to 3x plus 7. I'm going to subtract 3x. I have 6x minus 77 is equal to 7. You can add 77 to both sides. I have 6x is 84. Divide by 6. And you have x is 14. Again, they didn't ask us for x. They asked you to find MP. So this is MP. One thing that we do know in a rhombus is that all of the sides are congruent. So this is congruent to this. This is congruent to this. So we can actually plug this in to either side and see what the measure of MP is. So I'm going to plug it into this one right here. We have 3 times 14 plus 7. We'll see that this is 42 plus 7, which means this is 49. So if you want, you can use this one. I'm going to show you that these will give you the same value. 9 times 14 minus 77. If you do 9 times 14, you're going to get 126 minus 77, and that's still going to give you 49. So all of these sides are equal to 49. That is the measure of side MP. The next one asks us to find the measure of angle FED. So FED is actually this whole thing right here. This is FED. So it says CDF is a rhombus. Find the measure of angle FED. So again, this is a rhombus. What's different about a rhombus is that these two are congruent. So this angle and this angle are congruent. So we can just set them equal to each other. Again, this is because it's a rhombus. This does not work if it is a rectangle. So we have 8x minus 20 is equal to 5x plus 1. I'm going to move my 5x. So now I have 3x minus 20 is equal to 1. Add 20 to both sides. I have 3x equals 21. Divide by 3. And we get x is 7. They want us to find the measure of angle FED. But in order to find the measure of angle FED, we're going to first find this angle right here. So we're going to plug this in to either 8x minus 20 or 5x plus 1. It doesn't matter which one because they're both congruent. So if we find one, then we find the other one. So I'm going to use 5x plus 1. So 5 times 7 plus 1. This is 35 plus 1. So we know that this is 36. This is 36 degrees, which means this is 36 degrees, which means this whole thing is equal to 72 degrees. So let me go and write 72. So this whole thing is 72 degrees. Keep in mind, this angle, this whole thing, plus this angle that we're looking for, they are consecutive interior angles, which means they are supplementary, which means they need to add up to 180 degrees. So if we do 180 minus 72, we're going to get 108. So that is the measure of angle FED. It's 108 degrees. Let's try another one. So this time, this is a square. It says if STUV is a square with SW being 2x plus 13. So this is 2x plus 13. And WU is 8x minus 41. They want us to find VT. So in a square, remember the properties of a rectangle, a parallelogram, and rhombi apply to a square. So we know that these two are congruent. We can set them equal to each other. We're going to have 8x minus 41 is equal to 2x plus 13. I'm going to subtract 2x. Now I have 6x minus 41 is equal to 13. Add 41. And now I have 6x is equal to 54. If I divide both sides by 6, I'm going to get x is 9. Now they want us to find VT. VT is this diagonal. And the properties of a square show that diagonals are congruent. So even though we don't have an expression to represent VT, we can find, let me highlight this, we can find SU, and we can find SU by plugging x back into the equations that they already gave us. So you can plug it into either one. Remember, these two are congruent, so whichever one you plug it into, it applies to the next one. So I'm going to do 2 times 9 plus 13. 2 times 9 is 18. 18 plus 13 gives me 31. So if this is 31 and this is 31, that means the whole thing is 62. So if this diagonal is 62, that means this diagonal is also 62. So that is the value of VT. So VT is 62. Let's try one last one. Again, we have a square. It says if FGHI is a square, solve for x. So this time we're looking for an angle. Remember in the previous example, I said that every single one of these is 45. And it's 45 because they all make right angles. So we can say that this right here is 45 degrees. So we can just set this equal to 45. So 7x plus 3 is equal to 45. Subtract 3 from both sides. We have 7x is 42. Divide by 7. And now we know that x is 6. And that's all for this week.